Okay, cool. So let's start. So welcome to Percona Live. My name is Jobin. And today I'm going to talk about evolution of partitioning features in Postgres. And there will be very small demos as well to illustrate some of the concepts. Okay. And let's get started. Okay, so myself, Jobin Augustine, I'm working as a Postgres escalation specialist here. And here is my LinkedIn contact as well. Yeah. And first of all, why this talk is the Postgres got this partitioning features or a period of time, but still today. First, the old people are yet to migrate to new partitioning features, and surprisingly, this partitioning feature is becoming a important feature in which is triggering the migrations. And at the core, the partitions are table. So it is very simple, elegant, portable architecture. Partition table is a collection of tables. In fact, this architecture is different from what we see in other database systems. And in the declarative partition, the parent table does not it doesn't store data. It's a structure. That's it. Okay, so the evolution begins. So the prehistoric age of the partitioning. There were multiple attempts to solve this partitioning feature. So we, in old versions before Postgres 10, we were trying to solve this partitioning feature using table inheritance. And there is another method, the block range index. Basically, it is a virtual partitioning. Divide the table into block ranges. It's not real partition, but trying to solve the problem. Okay, and why the table inheritance is useful? Because Postgres is a object relational database. It's not a just relational database. Some of the object-oriented concepts are used in the database. One is the table inheritance is supported, and function overloading as well. So these are some of the object-oriented concepts we can see in Postgres. And this table inheritance can be used for creating subtables and child tables. Here is an example. We can create an table from another table by inheriting all its properties. The child tables can inherit defaults, constraints, indexes, storage, and comments. All the properties will be copied to the child. So it's a basically inheriting the properties. Okay, so let me quickly give a demo of that, the concept. To those who are not familiar with the inheritance of table. So here is my screen. What I'm going to do is I'm going to divide the screen into multiple windows, multiple pages, so that different versions I can show. Okay, so let me split the window into horizontally and vertically. Okay, and the first will be the Postgres 10. So I'm connecting to a Linux container of Postgres 10. So I'm putting a title there, PG10, and PG11 for this, 12 and 13. Okay, and now let us connect to each of the Linux containers. So the first one to Postgres 10, as we can see, it is connected to Postgres 10, and next to Postgres, 11 and 12 and 13. Okay, so this is how the windows are split. I'll be zooming in and zooming out whenever required. Hope you're able to see properly. And I'm just doing some housekeeping as well. Sorry about the connectivity issues. Okay, so coming back to the partitioning things, we were talking about the inheritance partitioning. I'm going to demonstrate the basic concepts. So I'm making sure that there is no let me connect to Psql in all the windows, all the versions. And I just want to remove the scrolling, the paging, and removing if there is no table like that. So let me create a table. So here is a table events. So it is created in all the versions, as you can see. And I'm going to create a index on that. Yeah, index is created. And if you describe the table, we can see that it's a simple table with one primary key and one index. So now, if we execute inherit, if you create a child table inheriting all these properties. So let us create a child table. So automatically in the screen it will be displayed what are the properties, what are the fields, the columns which is derived out of the parent table. And if you look at the child table, we can see that the child table as well as contains the same columns and same properties. Even the primary key and the index, everything is inherited. Okay, so back to presentation. So apart from the inheritance, we can even enforce some of the check constraints, because by which we can validate what are the data which can get into these partitions. So in this screen, we are seeing the created date between so and so should get into this partition. And due to this check constraint, each table can hold only the validated data. So it's while inserting the data, it will be validated. And Postgres has this constraint exclusion by which it can the queries can skip over the tables whose check constraint guarantee that there is no way to satisfy the condition of the query. So this is how the partitioning feature used to work initially. And so again, back to some quick demo. So let us do one thing. 1 second. Yeah, so let us drop this the child table which we created, and with the check constraints, we can just keep creating the partition like this. Okay, while creating the child table itself, we can mention the check constraint, so we can keep creating the as many child tables are which are actually going to act as child tables. Okay, this is the basic concept. I am not going to demonstrate the trigger and actual data insert. I hope the concepts are clear. So triggers are used for redirecting the tuples to right partitions. So so we need to have check constraints as well as the triggers. So this is how the Postgres partitioning used to work previously. And the problem with that approach is there is always the custom trigger overhead is there on every transaction, and the constraint exclusion method of is not intelligent enough. Only equality and range comparisons used to work properly. We often hear there is a very bad partition pruning happens with that method because it's not intelligent. And the biggest problem is that the partition maintenance requires a lot more involvement. Actually, we have automations like PG department, but still it's a lot more complex. And then Postgres 10 came. It is a big change. So the partitioning is no longer complex. It's not a revolution. It's an evolution. It is not an evolution. It's a revolution. It's a big change. And we have a new syntax for declarative partition. The table can be specified as partition by. So what is a column by which we are going to partition the table? This will act as the partition key. And in Postgres 10, we had range and list partitioning. Almost 95 to 99% of the tables will have range or list partition. Range partitions is the most common. So this can satisfy majority of the requirement. And by this declarative partition, it internally creates partition constraints and take care of the tuple routing. Earlier, the tuple routing used to handle by the triggers, but now it automatically happens. And it makes sure that partition bounds cannot overlap. So some validations will be there internally. And since Postgres uses the tables, internally the partitions are tables itself. So we have the facility to attach and detach partition. We may not see such things in other database systems. When we detach a partition, it becomes a normal table, and we can attach a partition and attach a table to a partition table. So it becomes a child kind. It becomes a partition. And another advantage is we can have a multi-level partitioning, because it's nothing but the child tables kind of. Okay, so a quick illustration. So I'm not going to take other sessions. So let me concentrate only on the Postgres 10. So I'm just trying to zoom this area. Okay, as we can see, it's a Postgres 10. Okay, so let me create a drop that table which we created, and it okay, we have, since it is child tables are involved, we need to specify cascade. Okay, and let me create a new table with the same structure. And we can have a partition for that table. Won't be storing any data, but say the events for Q1 Q1 from this range to this range of values it can hold. But this is a real table where the physical table where the data will be stored. As I mentioned, it can have subpartitions. So, but this is again, it's a partition definition. So this also won't be storing the actual data. That can have real part, the subpartitions, and it can have subpartitions. So now the partitions are created monthly. Earlier it was quarterly, and now we can have partition for a 2 quarters. Yeah, so it's very flexible, and there is no constraint. So this declarative partition in Postgres 10 saved a lot of problems which we had to deal otherwise. And even it gave really exciting features like the partition need not be local. It can be on a remote machine as well. So a foreign table can be a partition of a table. So this is kind of sharding. So it uses PostgreSQL FDW behind the scene. So really exciting features in Postgres 10. So is there any problem? Let me demonstrate a problem. The same table I'm creating, you see, it is not allowing us to create a primary key. So one of the major requirement is not satisfied. So this is a problem in Postgres 10. So no unique key is possible, no primary key is possible, no foreign key is reference to other tables possible. So I used to say the keys are missing, the key features are missing. Yeah, and that's a time when Postgres 11 comes. It is fixing all practical problems related to the partitioning. And sorry. What is the major feature of Postgres 11? The Postgres 11 came with hash partitioning, which was not there in the Postgres 10. And many of the customers who migrate from other database systems were looking for the hash partitioning, and it is available in Postgres 11. Yeah, even though the use cases are less, the feature is added. And of course, the keys are supported. I think yeah. So for example, say I'm create. So this is a Postgres 10. So let me quit this. And go to Postgres 11. Sorry for the trouble. Let me drop the table. And so here is an example. So I'm going to create a partition table by range, and I can create a unique key on the table and a primary key on the table. If I have another table, I can even create a foreign key reference, so no problems. So this is a big change for all the practical problems related to keys in Postgres 10. And another thing is the migration. So the data migration from partitions. Let me explain what it is with an example. So, for example, in this table, if I have a partition for the range from 1 to 5, so let me create that. Say for the values of 1 to 5. And another partition for 5 to 10. And let us describe and see how it looks. There is a primary key and a unique constraint which we created. Let us drop that foreign key because it will prevent us inserting some data. And here it how it looks now. And let us insert a value 2 to that. So since the partitions are from 1 to 5, the record should go to the first partition. So let us examine that. The data is there in the first partition, not in the second partition. It's 0 rows. And what will happen if we update the data? So we updated that to value of 6, and the partition key is updated to value of 6. So the data is no longer there in the first partition. It is moved to the second partition. So the data gets migrated to other partitions. This is a very important feature which everyone was looking, and it is there in Postgres 11. And another important thing is catching the following. So let me explain what it is. So for example, we have now partition for a range 1 to 5 and 5 to 10. So what will happen if I update the value to 15? So let's try. Because there is no partition for that, it will fail and it will error out. So let us, the Postgres 11 gives us a facility to create a default partition. So we can create a default partition, and now if we update, the data goes to that default partition. So if no other partitions can satisfy that constraint, if the data goes to the default partition. So this is again important, because when somebody convert a non-partition table into a partition table, they shouldn't get unexpected errors like this. So it should be handled properly. Yeah. So Postgres 11 introduced default partition, and it is important to avoid unexpected failures. Okay. And another important feature is the automatic index creation. So we can define the indexes on the partition level, partition table level, and it will be inherited to each partition. Yeah, but I'm not demonstrating that, but in addition to that, we can even create partitions in individual we can create indexes on individual partitions, so that won't be cascaded to other things. Okay, and I'm moving on. And another big feature in Postgres 11 is partition-wise aggregation. By default, the parameter it is turned off, and we can turn it on, and it can do a lot more magic. So let us see that. So I'm turning that partition-wise aggregation to true at the session level, and I'm creating a list partition. So for specific values 0, 1, 2, 3, and up to 11. So I have 3 partitions now, and I'm going to insert some data there. So 3,000 records are inserted, and analyzing that partition. And if you say group by, we can see that the partition-wise aggregation is performed. So here it is on the partition 1, and it is on the partition 2, and this is on the partition 3. So this is a big improvement in terms of performance. And even if the group by clause is not on the partition key, still it performs partition aggregation. It does partial aggregation using the partition-wise aggregation feature. So here it is here is an example. So as we can see, partial aggregation happening. Okay. So there is lots and lots of features in Postgres 11. So it solved a lot of problems. So again, is there any more problems, any more complaints in Postgres 11? The biggest problem was the planning time. Actually, this number is coming from one of our real customer case. So planning time is 150 milliseconds. Actual execution is 5 milliseconds. So when we have a lot of partitions, analyzing all the partitions and figuring out which partition it need to be scanned, it takes time. So this was one of the demerits of Postgres 11. And yeah, the planning time is very high. And again, partition pruning is not very intelligent. So there were many cases people reported this is not the way it should be planned. And the biggest complaint we used to hear is after partitioning, we are not seeing everything works fine, but we are not seeing any benefit. The performance is not improved, and sometimes we even heard that it is even worse than the unpartitioned table. These were the common complaints, and that's another problem is that the performance was degrading as the partition, the number of partitions were increasing. And that's the time Postgres 12 came. It's really, really fast. And here is an example. I'm not going to do live demo. So in Postgres 11, we can see the planning time was around 181 milliseconds. The same table on same machine and same only just Postgres version change. The planning time decreased to sub-millisecond range. So overall, we started seeing a lot more improvement by just upgrading the Postgres version. And the planning time is not just affecting the select statements, it's affecting even update statements. Here is an example. We can see the difference in the planning time. And there are other parts of performance improvement, say bulk data loading. So there were reports that up to 40% improvement in bulk data loading, and even simple logical dump and restore of the data. We can use it for even partitioning a table. To partition and partition table, we can even do logical dump and restore. It works much faster in Postgres 12. So this is a great improvement. And the insert performance improved. And the primary key lookup, it's also become several times faster. There are reports like hundreds of times performance gain. And the underlying reason for this is the metadata loading is performed after the partition pruning. That was one of the biggest change happened. So I'm just mentioning one of the good blog posts regarding that from the second quadrant. And other set of improvements. There were unnecessary plan nodes in Postgres 11. So in this case, we can see the merge append. And in Postgres 12, that entire step is removed because it knows that is unnecessary. The entire data is coming out of a single partition. So there is no need to append anything. And there is a lot more, lots and lots of improvement in Postgres 12. These are some of the listing of all the changes. I'll be sharing these slides with everyone. So the links are provided for all the commit related information. The page table, total table pages, the calculation is postponed until partition pruning. This is which I mentioned earlier. It gives a better planning time. And the second one gives another performance boost, the partition pruning remapping. And redesign the initialization of partition routing structures. This is where the tuples get routed to each individual partition. So this is going to speed up insert, update, delete, and copy operations. And the delay in lock acquisition. So this improves the concurrency and less contention in partition tables. And I'm not going to each of the details, so I'm skipping over. And obviously the question comes, okay, we are talking about a lot of performance improvement in Postgres 12. So is there anything else other than performance improvement? So it's not just performance improvements. There is a lot more partitioning features also. One is the attach partition. Attach operation become non-blocking, and it is not blocking any select statement or vice versa. But detach is not yet concurrent, and because there were some initial slides somewhere it's mentioned even detach is concurrent, but it's not the case. Detach is not concurrent, and there is no separate syntax, so automatically it happens. So when we attach a partition, it by default it won't be blocking. So you don't have to have any special syntax as such. And this is another improvement, the foreign key reference to partition tables, so the foreign key reference by the partitions is easier, but foreign key reference to partition table is much more complex because the data could be sitting in multiple partitions. So let me show you an example of that. I'm creating a new table called trading. It's all about share trading. So it is partitioned based on the trading date, and I'm going to create another table for all the exceptions happening during the trading. So we can see it's a multi-column primary key. Now it is possible in Postgres 12 to now we are you see we are in Postgres 11 terminal, so this is going to give trouble. Okay, so we are getting errors as expected. So let us disconnect from here and go back to Postgres 12 and do the same thing real quickly. Two tables are created, and we are trying to establish a multi-column foreign key reference. It works. So this is one of the major complaint which people used to Postgres 11 we used to get this error, but in Postgres 12 we can have the foreign key reference. And another thing is partition boundary by expression. So what it means, what is that? So let me show you. Say, for example, if we have a table like a single column, and if we want to create a partition, normally we need to give literals, but in Postgres 12 we can give even expressions as partition limits. So here is an example. So we can create a partition specifying that this partition is from today and right now and 5 days till 5 days ahead. This was not possible earlier. So this gives us a lot of scripting ability to create partitions. So we can have functions or expressions by which we can decide on the partition limits. Okay, yeah, so that's what Earlier, only literal values were allowed. Now, general expressions, including function calls, which were it is evaluated at the time of DDL command. So when we create a partition, that's the time this expressions will be evaluated and partition limits will be decided. And this is another improvement. We can specify table space at the partition level. Because earlier it was a limitation. Say, for example, I want to have some default partition for upcoming partitions. So now I can just go and create table space, the default table space for the partition table. So all the upcoming partitions will be going to that table space. Say, for example, hope you know all the concept of table spaces. Say, if you have frequently used partitions where most of the transactions are happening, you may want to keep it in a high speed device like SSDs, and all the partitions you may want to move to a slower disk. So we can define all the new partitions to come to the new SSD. Yeah. So sorry. So here is an example. So I'm dropping that table and creating a table space. Okay. Okay, I already created that table space. And now suppose I have a table. Okay, it's already exists. Okay, and now if so for example, if we have a oh, 1 second, let me do the cleanup. Okay, let me reattempt. Table is created and a partition is created, and now at this stage I can set the default table space of the upcoming partitions. So alter table. I am specifying at the table level. All the new partitions need to go to this new table space. And if I create a new partition, we can see that that goes to the new table space, while the old one remains in the old partition. So this is this helps us to maintain where to place the partition. Okay, and all the new partitions created will be using table space specified at the partition table level. Yeah, it can be specified at the create table time as well as we saw in the alter table command as well. Okay, and moving on. And Postgres 12 introduced a lot more partition-related functions. So here is an example: PG partition tree. So frequently we may get a question like, how is the partition structure looks like? And this is usable even in the scripting. So you may want to have different levels of partitions, and you may want to get the root. So we have a function for root for a particular partition, and find out the ancestors. So all these functions are really helpful for DBAs as well as who are scripting all these things. And another change was that we know this PG indexes view in Postgres. This holds the index related information. In Postgres 11, we never had the index definition listing in this view, but that is changed in Postgres 12. And let me see whether I can demonstrate that. If I create a table and create an index, we can see that it is there in the PG class as a object. And since we are in Postgres 12, we'll get the table, the index definition. Okay, but the same thing won't be happening in Postgres 11. So this is an improvement for the very useful for DBAs. Okay, back to slides. So Postgres 11, it used to give empty rows, and Postgres 12, we have the clear index definition. And not just the server-side features, we have a lot more client-side features as well in Postgres 12. We have Psql meta command /d capital P. This is something new. It can list all the partitioned tables and all partitioned indexes. And we have that clearly mentioned when we describe a table. It's as we can see, it's a partitioned table. And even when we check permissions, it will be clearly mentioned it is a partition table. So these are the improvements for the client, say PSQL, the command line utility, when we deal with the partition tables. This makes our life simple. And Postgres 13. The Postgres 12 made a really big leap jump in terms of the usability and performance and in every aspect. And it made really fast. So we have all the features and all the benefits of partitioning in Postgres 12. So do we have anything more left? Yeah. So Postgres 13, it is going making it more cool. So here is a example. In Postgres 12, we could not have a before trigger on partition table. It used to error out, giving this error. But in Postgres 13, we can have a before trigger on a table. And the trigger which we create on the partition table will automatically get inherited onto all the child partitions as well. To give demo, let me try this. Okay, this is Postgres 12. Okay, what I will do is I'll make sure that both Postgres 12 and 13. So let me pull this sidewise so that you can see both at a time. And I'm just synchronizing the panes. 1 second. Yeah. Let me try whether such a table exists on both. Making sure that there is no table, and creating a table on both the Postgres 12 and 13, and creating a partition by list. And for value 1, I'm creating a partition. 2, 3 and 4. And now if we insert a tuple, insert a row into this table, say with the value 1, we can see that it goes to the first partition in both the cases in Postgres 12 and 13. And what will happen if we update this to 2? We already discussed the rows will get migrated. So when we update to 2, it will get migrated to the second partition. Okay. And what will happen if we implement a trigger on this? So let us truncate this table and create a trigger on both 12 and 13. This is a trigger function. When we create a trigger, Postgres 12 errors out, it is not possible, but Postgres 13, as we expect, it allows the trigger. And we can have multiple triggers before triggers as well. So just for demonstration, I am using the same trigger function once again. And now what will happen if we insert a record? So insert a record as earlier for the with the value 1. And if we update the record with the increment by 1. So as we know, in Postgres 12, it should go to the second partition. What will happen for 13? Because we have triggers as well there. As we can see, in Postgres 12, it goes to partition 2. And for Postgres 13, it goes to partition 4 because it incremented 2 times because of the trigger. So we can manipulate where the is going using the before triggers. And there is better partition pruning happening in Postgres 13 than Postgres 12. As we can see, there is it become more generic. So even if the query is hitting on a subpartition, the partition exclusion, the constraint specified in the parent table will be applied for that. So in this case, the same query is executing in Postgres 12, which actually goes and checks all the partitions. But in Postgres 13, it's straight away figuring out none of the partitions can satisfy the condition. So it comes out. And even the advanced partition matching, the partition matching is there in Postgres 13. I'll be discussing this in the upcoming talk. I have a back-to-back presentation for Postgres 13. So I'll get talk more details about this. Yeah, sorry that I started a bit late. And partition table can be part of replication logic, and not just publisher, it can be part of even the subscriber. So earlier it used to be each partition has to be specified in part of as part of the publishing and the subscriber, but that's not the case anymore. And the partitioning improvements are not just happening because of the major versions. There are some of the improvements are even coming in minor versions. So please keep upgrading. You are going to get a lot more benefits. Here are some of the examples for. So hope you get the feel when you upgrade, and some of the quick references. Yeah. And sorry, I'm running out of time. And please keep posting the questions. And welcome to the other session, which is going to happen on the room number 5, where I'm going to discuss about Postgres 13 features. And I'll be covering this partitioning features in Postgres 13 as well. Thank you, everyone.